Hi everyone. Now we are going to discuss about BJT small signal amplifier circuit. Here we are considering the base to emitter voltage as 755.05 millivolt and we are going to apply zero point 0.1 millivolt at the base terminal of the transistor. Here we are considering thermal voltage of the transistor at room temperature will be 26 millivolt, that is Vt is equal to 26 millivolt, and Vb is equal to 0.75505 volt. And here output resistance of the transistor will be very high and the base current will be very negligible. And here we are going to find the gain of the amplifier circuit, that is V out by V in. To find the voltage gain, we have to find the small signal equivalent circuit of the amplifier. So we need to replace it by the small signal model. This is a small signal model of the amplifier circuit. In this model, initially we have to find the transconductance. The transconductance for the bipolar transistor can be expressed as Gm is equal to Ic divided by Vt. And we know that thermal voltage of the transistor at room temperature will be 26 millivolt. So as per this equation, we need to find the collector current IC. To find the collector current, we need to do the DC analysis. For the DC analysis, all the capacitor act as a open circuit, all the AC input act as a zero. Then the equivalent circuit will be like this. So now we have to find the collector current. As we discussed, the here we have considered the base current is very negligible, so that the beta will be very high. When the beta is very high, the collector current IC is approximately equal to emitter current. To find the emitter current, we need to apply the KVL rule in this loop. So as per KVL rule, 0 volt minus VBE, base to emitter voltage, minus emitter voltage minus of minus 20 volt, which is equal to 0. And already we know that the base to emitter voltage is 0.75505 volt. That emitter voltage V is equal to 20 volt minus 0.75505 volt. And also we have aware of that emitter voltage V is equal to the emitter current IE into and the emitter resistance RE. That means the emitter current IE is equal to 19.245 volt divided by 40 kilo ohm, which is equal to 0.4811 milliamps. So that transconductor GM is equal to IC divided by VT, which is equal to 4811 divided by 26. This is the value of transconductor. Once we know the value of the transconductor, we need to go for the AC analysis to find the current gain of the transistor. For the small signal analysis, if you see the equivalent circuit as like this. That means here coupling and decoupling capacitor will be act as a short circuit and DC source also act as a short circuit. Because of the bypass capacitor short circuit, the emitter terminal of the transistor will be grounded. So now the input will be connected between the base terminal and emitter terminal of the transistor, and output will be connected between collector and the emitter terminal. And we can replace this by the small signal model. And as per this model, the output voltage V out is equal to minus IC times collector resistor RC parallel with load resistor R. As you see here, input voltage V in equal to V5. So that output voltage V out is equal to minus GM times V in into RC parallel with RL. Or we can say that V out divided by V in is equal to minus GM times RC parallel RL, which is equal to minus 0.4811 divided by 26 times 20 kilo ohm parallel to 20 kilo ohm. So which is equal to minus 0.481 divided by 26 times 20 kilo ohm parallel to the 20 kilo ohm, and which is equal to minus 0.4811 divided by 26 into 10,000 ohm. And when we simplify that, we will get minus 185.05. So we can conclude that the current gain of the transistor will be minus 185.05. Let us verify this in simulation. Here we are going to apply zero point 0.1 millivolt AC signal at the input, and we are getting the output voltage as almost nearby 185 times of the input voltage. By considering this circuit, and we are able to understand how to amplify the small signals. I request you to kindly subscribe and like the video. Thank you. Thank you for the watching.